Welcome to The Explainer, where we break down big ideas into clear, engaging explainers.
Modern AI, it pretty much runs on data. Think about it. Those large language models you chat with, the algorithms that know exactly what movie you want to watch next, it all starts with just massive, massive amounts of data. But here's the thing, not all data is created equal, not even close. In fact, there's this huge tension right at the heart of AI development, and it all boils down to two very different kinds of data. Okay, so on one side, you've got your labeled data. This is the good stuff, the gold standard. Every single piece has been hand-tagged by a person. Super accurate. But man, is it slow and expensive to create. And on the other side, you've got unlabeled data. This stuff is everywhere. It's cheap, it's abundant, but it's totally raw. And AI has no idea what it's looking at. And that right there, that's AI's billion-dollar problem. Seriously. Our most powerful models, they're hungry for these enormous, perfectly labeled data sets. But actually creating them, it's often just not practical. It is this massive bottleneck holding everything back. So, you gotta wonder, right? What if there was a middle ground? A way to get all the power of that perfect labeled data, but without the absolutely crippling cost? Well, that's exactly where this brilliant idea called weak supervision comes in. You might also hear people call it semi-supervised learning. And trust me, it is a total game changer. At its heart, the idea is so simple, it's beautiful. You take a tiny bit of that expensive, smart labeled data, and you use it to help the AI make sense of a huge amount of that cheap, raw data. Think of it like this. A teacher in a classroom doesn't solve every single practice problem on the board, right? Of course not. They just walk the students through a few key examples, and that's usually enough to give them the tools, the intuition, to figure out the rest on their own. Okay, but how does this actually work in practice? I mean, how can an AI possibly learn from data when it has no answers to check against? It sounds a little bit like magic, doesn't it? Well, the secret isn't in the labels at all. It's actually in the structure, the hidden patterns buried inside all that unlabeled data. All right, check this out. Let's say you only give an AI two labeled examples, this one black dot and this one white dot. With just that, what's its best guess for separating them? Well, it's just going to draw a straight line right down the middle. Simple, but not very smart. But now, look what happens when we let it see all the unlabeled data, all those gray dots. It doesn't know what they are, but it can see their shape. It sees the natural clusters and curves, and suddenly it can draw a much smarter, more accurate boundary. It's like it's getting a feel for the landscape. So this intuition, it feels like magic, but it's not. It actually works by making a few really clever assumptions about how the world works. First up is the smoothness assumption. Basically, if 2 points are really close together, they're probably the same kind of thing. Makes sense, right? Then there's the cluster assumption. This says the data usually forms into natural groups or clusters. And again, if you're in the same cluster, you probably share the same label. And finally, my favorite, the manifold assumption. This one's a little mind-bending. It suggests that even really complex data, like all the different expressions on a human face, is often controlled by a much simpler underlying structure. Think about it. Just a few muscles create an almost infinite number of expressions. And look, this is way more than just a cool computer science trick. This clever compromise is changing, well, pretty much everything. It has huge real-world implications. You're seeing it in action all the time. It's a key ingredient in the large language models we use every day. It's being used in factories for something called predictive maintenance, where it can spot failures before they even happen. It's what's behind so much image recognition and language translation. It's analyzing customer sentiment. It's even writing creative text and synthesizing speech. It is everywhere. What this does, really, is blur the lines. It creates this powerful hybrid approach that takes the best of both worlds. You get the creative, pattern-finding genius of unsupervised learning, but you combine it with the accuracy and precision of supervised learning. It's a perfect match. But you want to know the most surprising, the most incredible application of this idea? It isn't in a machine at all. In fact, this cutting-edge AI concept is something you've been an expert in your whole life. I mean, just think about how a little kid learns about the world. A parent points and says, "That's a dog," or "Careful, that's hot." That's a tiny bit of labeled data, but the vast majority of their learning, it comes from just experiencing and observing the messy, unlabeled world all around them. We've been using weak supervision our entire lives. From learning to recognize any dog after only seeing a couple of examples, to figuring out super complex social cues, we're constantly using a few key examples to make sense of a lifetime of raw, unfiltered experience.
So, when you boil it all down, the key takeaway is this. By teaching machines to learn a little bit more like we do, with less handholding and more independent observation, we're doing more than just solving a data bottleneck. We are unlocking the potential to solve bigger, more complex problems than we ever could before. We're fundamentally expanding what's even possible for AI. And that leaves us with a pretty fascinating thought. If machines can start learning more effectively with less direct human guidance, how is that going to change the way we tackle the world's biggest challenges? What becomes possible then?